All right, everyone is back. Not yet. It's started. Just before I explain what is the new algorithm that we are going to do and what it does, maybe we can just get ready for data IQ. So I want you to download one file. You will see folder, which is decision tree plus k means, and the file I'm referring to is iris, IRIS. You would see a iris CSV file. So please download that, keep it ready. You can even open it in Excel and see what is inside. So this one, yeah, that's right. Yeah, correct. So decision tree essentially is meant for categorical. There is a version of decision tree which is called regression and classification. Regression tree. So not what it means. The one that we are using is only for category. Yeah. So just for your reference, it can be used for numeric, but it's a different variation of the tree. It's called regression trees. Regression decision tree, which can be used for numeric also. But from this module perspective, just consider category. Sorry, Ash. On the trial mode. We'll be using it on the trial mode. Don't import it on data IQ yet. Let's have a look at clustering first. What is this algorithm? What are we trying to do? Okay, so brand new algorithm, completely different from what we have seen before. Different type, different learning, different purpose, and very different execution. Quickly, please. So far, what we have done is supervised learning. We started with regression. We went on to logistic regression for categorical data. We went on to decision trees again for categorical data. We went on to random forest again for categorical data. And all these algorithms, so far, we were referring to supervised algorithms. Welcome to the first official unsupervised algorithm, which is called clustering. Okay. Now, remember, just like regression, clustering is a broader term. You have linear regression, you have logistic regression, and so on. Again, clustering is a very broad term. There are various algorithms that can do clustering for you. The algorithm that we are going to see today is something called k-means algorithm, which allows you to do clustering. Okay. But the big question, what is clustering and why is it considered unsupervised learning? Okay. Anyone has any idea of what is clustering? Has heard about this term before? No? All of you are new to it? Yeah, what is clustering?
So something like arranging a similar type of.
That's right. Another kind of records into one group. Okay. Let me give you an example. Let's talk about student data. I have all your data, your age, qualification, etc., etc. And I am asking a machine learning algorithm that can I have three groups of students in this class? Listen very, very carefully. I have all your data. I have 10 columns of your data. I upload these 10 columns and I say, can you come up with three groups in this student data set? I'm not saying based on what? I'm not saying form groups based on age, form groups based on academic performance. I'm not giving any input. The only thing that I'm saying, can I get three groups of students from this entire data? Since I'm saying I want three groups from this entire data, there is no that I'm predicting. Find out whether student will pass. Based on similar patterns, can you find three groups inside this data set? That is the reason why this is unsupervised learning, because there is no one variable that you're predicting, you're calculating, you're estimating. It is forming groups within your data set. Now, why you have to be ultra careful with unsupervised learning? Remember, everything in machine learning, everything is AI, is eventually mathematics, nothing else at the end of the day. Now, what algorithm will do, it will calculate the distance between your marks and age and this and that, and then try and find those which are commonly related, try and find those which are closer, etc., etc. And it will tell you, these students are group one, those students are group two, and these students are group three. It will do the job. Now, whether the job was meaningful or not, as a human, you will have to sit and analyze. Remember, the job that the algorithm did was from a mathematical point of view. It does not know that this column is age. It does not know this column is mass. For the algorithm, everything is numbers, right? Based on the numbers, based on the math, based on the Euclidean distance, it has done everything. It has given this is group one, this is group two, and these students are group three. Job done and dusted. My question to you, as a human, how can you understand whether this grouping was meaningful or not? Now, let's say you gave to the algorithm student data, this student data. All of your data I had, I gave it to the algorithm. I said, can you please form three groups? It said, this is group one, that is group two, and all of you here are group three. How would you understand? Great point. Now, as a human, let me first talk about her answer. She says, as a human, you find out if there are any patterns. Okay, show me the average age in group one, show me the average age in group two, show me the average age in group three, and then I understand, oh, there is a difference. Maybe group one can show the academic performance. Compare it to group two, compare it to group three. In group one, show me average experience. Compare it to group two, compare it to group three. I start taking my notes on what is common in group one, how is it different from group two, how is it different from group three. The biggest problem of unsupervised learning is there is nothing you can compare. How can you say this is accurate, right? You cannot say, oh, actually, these guys were in group one and it matched. Actually, those guys were in group two. These groups never existed. That's why I went to unsupervised learning. Unsupervised learning did the job. The only way to know whether it was meaningful or not is for you to draw and understand patterns, draw graphs, find out what is common in group one. Of course, the tool will help you. It will say the average of age, educational experience, and academic performance is this for group one. It is this for group two. It is this for group three. So I can understand from what it does, but I would explore more and I would say, are these groups meaningful or purely by mathematics, it has just given me. And remember, it will never say no. This is again the biggest problem of AI. You give a task, it will run it. It will say, this is group one, this is group two, this is group three. It will never say, sorry, these are not meaningful groups. You will have to sit down and understand whether this is a meaningful grouping or math has done the job. Otherwise, there is no concept of accuracy. If there is no concept of accuracy, there is one big difference between what you have seen so far versus when we implement this in data IQ. Can anyone tell me what's going to be the major difference? So if you remember, what did we do so far? We had a data. We used to prepare the data. We used to have a training and testing. We used to apply the model on train, test it on test. Now I'm doing unsupervised learning. Where do you think will be the biggest difference when I do unsupervised learning compared to the process that I've seen so far? Sorry? There is training and testing. Okay. Any other guess? What will be the difference in unsupervised learning versus supervised learning from a process point of view? Will we still do preparation? But one by one, will we still do preparation? Yes, there will be some missing values, there will be something, you would still do preparation. will we do training and testing in unsupervised learning? Why will we not be in a position to do training and testing? Why can't you? You don't have parameters. Which parameters you don't have? We have. So let's say we have age, we have qualification. So imagine we are doing student data. I'm trying to form 3 groups from your class. I have your age, I have your gender, I have your academic qualification, I have everything. What stops? That's right. And what is the target variable here? What is ultimately trying? The group numbers, right? Now, let me take back examples that we have done. What were we predicting in that data set? You remember which use case was that? So, okay, and for the fact that it survived or not? Yes, it was there. So now it's very easy. You have a training, you have a testing. In the test, ask the model to predict, compare it with the actual answer, and you get the accuracy. We moved on to decision tree. What was the use case? What did we predict in decision tree? Credit card, sign up. Whether a customer would sign up for the credit card or not. Did we have a column which said yes or no? Yeah. So now you have a training, you have a testing. Let the model do the prediction, compare the answers. Now I have student data. I have age, gender, educational experience, academic performance. I have everything, but I don't have that column that says following students are in group 1, following rows are in group 2, following rows are in group 3. I don't have that. It's completely not there. So with unsupervised learning, I'm trying to create that column which never existed at the first go. There was never a column that said they are in group 1, they are in group 2, you are in group 3. That variable itself does not exist. And in those cases, I go for clustering, which is one of the ways of unsupervised learning where I am doing grouping within the data set. And were these students actually in group 2? Were you actually I went for clustering. So there is no testing, no training. You have to provide up to you. Whether it was meaningful or not, you need to find common patterns. If you find good patterns, you would say, yeah, group 3 is really different from group 2. Group 2 is really different from group 1. Next question. Do you find any realistic use case? I would never use student data for doing grouping. In a real industry projects or use cases, where do you think you can form groups of what? Where do you think this grouping can help you? Prediction, we all know a lot of interesting use cases. When you know what you're predicting.
The window size of property, we can group people among the people who are might be interested on the villa.
Very interesting.
Or if you have 1 BHK.
Love that answer. Love that answer. Now, let's say you have a full database of all the people who are interested in property market, all the leads that you have in the real estate company, and now you're saying, can we do some grouping to understand, oh, these set of customers have certain preferences, these set of customers behave very differently, these set of customers behave very differently. And I'm not saying based on what. I'm not saying based only on the villa preference or apartment preference. It could be based on long term. It could be based on off plan versus buying versus renting. I give every data and I ask, can we cluster these people so that my marketing strategies could be very different for group 1. If I find effectively nice groups, it could be very different for group 2. It could be very different for group 3 and for group 4, depending on how many groups you're forming. Fantastic use case. Anything else? Healthcare. Absolutely, you have, let's say, all the records that you have. Can you form clusters? Can you form groups of those records? And again, customer segmentation. Let's say, your company is trying to come up with a loyalty program, and they are saying we just don't want based on only the loyalty to have gold, silver, and bronze. Maybe we want to find patterns. Some patterns that could lead to one set of customers who are effectively very different from others, effectively very different from others. You can do clustering. Telecom is a big player in clustering. So all these packages that you see with bundling offers and everything, they actually do clustering and they say what type of people would buy social media at a certain amount. There is another group of people who have their data usage low, but their call volume is high. International call volume is really high, so on and so forth. Again, grouping is a very important concept in unsupervised learning where you're open for answers. You don't know if you will be able to hit it. You don't know if you will be able to find something good, but you want to run the experiment and see.
E-commerce companies such as Amazon.
Very good.
If you select one product, then it automatically comes with what product you should.
Very good. And in fact, K-means clustering is the algorithm behind recommender system. They actually do clustering, which products are often brought together, which products are not. And K-means is one of the foundational algorithms for the recommender system. In fact, e-commerce is one of the biggest players in clustering. And let me show you one very interesting case study of that e-commerce. Now, long back, they actually published this case study purely by K-means clustering. Now, what they did is they said, we have so many customers who have purchased from our e-commerce website. Let's try clustering. Let's see if we find groups of customers. Let's see if one group behaves very differently from the other group, behaves very differently from the third group. They actually did 4-group clustering, and you can choose. You can choose if you want 3 groups, 4 groups, 5 groups. The K in K-means actually stands for number of groups that you want. Okay. Now, listen to the story. Quite phenomenal. I'll share the whole PDF with you. It's a fantastic case study. They did this clustering and they used K-means. And K-means said, okay, I'll do the job for you. These are the customers in group 1. These are the customers in group 2. These customers in group 3. These customers in group 4. What do you think the company did after getting those group recommendations from the algorithm? What should be the next step for the company? Sorry? But before that, how do they know these groups are really good groups? Yeah, possible. So looking at different variables of group 1, comparing it to group 2, sorry, frequency of purchase of group 1, maybe analyzing it with return rates in group 1, are they different, are they same? This is what the company did very nicely and look at what they found. So here are some interesting graphs. By the way, the colors that you see are the output of the algorithm. Algorithm has already done the job. It has given so many customers in group 1, some customers in group 2, some customers in group 3, some customers in group 4. What the company did, they said, let's analyze it in 2-dimensional graphs, one by one. They took the first graph. What do you see is on the x-axis? Purchase frequency. How often do consumers purchase? And what is on y-axis? Return rate. Now, the moment they did this for the 4 groups, which the algorithm gave, they found something interesting. And they said, look at the B group. There is something very weird and very different about these guys. What is the common property of group number? They have the highest purchase, but they also have a very high return rate. Now, this is where they started analyzing. They said, oh, this is a very interesting group. At one end, they have features that we like, which is they purchase a lot. But at the other end, they have features that we don't like, which means they return a lot. And now they started this group alone is a Pandora's box for the company. They said, we can start analyzing the way we want. Number one, we can analyze, are these guys returning the products because of return more, or shall I check historically what products they purchase. Is it returning a lot? That group alone opens exploration possibilities for the company. They would say, I would love to investigate that group. Why are they returning a lot in spite of the fact that they are purchasing a lot? And you can see that green group behaves very differently compared to the other three groups. The moment you see that graph, which is showing some exhibitly some really different characteristics compared to the other groups. Let me one more interesting group, the red group. There's something interesting about these guys. Return rate is very low, and also it's not very much variable in the return rate. If you see, all of them have pretty much return rate. With the second graph. Now, return rate comes on x-axis, and the monetary value that they bring in comes on the y-axis. Now, you would say that green group's monetary value is probably the lowest compared to all the others, which is explanatory because they return a lot, so they get the refunds, and the monetary value goes down. However, one thing interesting to note is this group as well. Group number 4. Now, these guys, purchase frequency is the lowest of all the customers. Okay. What about their return rate? Is that favoring the company or against the company? Favoring, fairly okay. Not of course, slightly higher than the red group, but still much lower than the green group. Now, imagine how company is thinking. They are saying these people have the lowest purchase frequency, very good in terms of the return rate, but the monetary value is pretty good. In fact, even higher than the red guys. Yes, exactly the kind. There is a word given in business terms for the company. This is cash cow. They would say, "Oh, these are the people who buy less, but their pocket size is pretty high, and because their pocket size is high, the overall monetary value that they bring into the company is way higher." And trust me, this was a gold mine for the company. They what we need to do, we need to target to shift over there slightly here. Why?
Small ticket purchase will give up.
The small change in purchase frequency because of the big pocket items would actually lead to significant impact in the monetary value, which is what the company did. They said, let's do very targeted promotion. They are like premium customers for us. Let's try and make sure that they purchase a bit more, not too much more, a bit more, so that our monetary value can be impacted. And they just published the whole case study. They also about these guys. And they said, they are returning a lot and we are losing money because we are giving them a refund straight away. Let's stop that policy. Let's introduce cash coupons as the first level and say that, okay, you have to return the product if it is for here's 100 and buy something else on the same website, which means not losing that monetary value, keeping the monetary value within the firm itself, so on and so forth. They did practically everything they could do for group 1, for group 2, different marketing campaigns. It's a nice case study. I'll share that with you. But remember, all the drama happened after algorithm did the job. And that's the most problematic part about unsupervised learning. Algorithm is not complicated and it's very easy. You click a button and it will form the groups for you. Whether those groups were meaningful or not, that's a post exercise challenge that everyone will have to sit and analyze, do pivot tables, do graphs, try and find the patterns. That's not where the algorithm helps you. It only helps form groups and clusters.
So it's like real world companies. So there are like
This was real world. This was a property commerce company in US, and they published the whole case study. So this was a real world exercise. They did K-means itself. They mentioned the algorithm also. They said we implemented K-means, we took four groups, we asked the algorithm to give us four groups of customers. They gave all the graphs that they made. These are the graphs that we analyzed completely.
What's the company name?
I forgot it was, and now that company even does not exist. And you can actually imagine it was an old company because now pretty much every company has the cash, I mean the coupon kind of system where you don't directly give the refund. If you want, you get, but then they encourage that you have those coupon. That time it did not exist. I'll share the PDF. I'll share it on my learning. Any other question before we see something interesting about the implementation? Shall we go ahead and implement in Data IQ? Okay, let's do this. So once again, those who came late, in week 6 folder, there is this iris data set, iris.csv. And I would recommend doing this in your new Data IQ license, not the MDX one. So you get comfortable with the launchpad. Let's create a new project, call it unsupervised. It's a fun data set that we are going to take for unsupervised learning so that you understand how amazing the algorithm is. Everyone, please load the data on your screen. Need any help? Okay, so no, for part one. Okay, so then you continue here itself, make a project here and download Iris and bring it in the Is everyone with me? Shall we get started? Okay. Now, here's a very interesting data set, but I would issue a warning here. The way we are going to do this is not truly the real use case of the algorithm. Let me explain why, and please listen very, very patiently. Now, take a guess on what do you have in each row? What is row 1, row 2, row 3, row 4? It's a flower data set. You have flower 1 in row 1, flower 2 in row 2, another flower in row 3. You have the dimensions of the flower, sepal length, sepal width, petal length, and petal width. Last column, you also have one critical piece of information, which category of flowers it is. Okay. Question to you. Can you quickly analyze the species and tell me how many categories are there and how many flowers are there in each category? Fantastic. That's the response I want. 3 categories. Which are the ones? Setosa, versicolor, virginica. And how many in each? So total 150 flowers. Okay. Now, please listen very, very carefully. And why I'm telling you this is not the ideal way to do unsupervised learning. We are just trying to have some fun here. And what is the fun is we are trying to see, can mathematics and AI understand nature on its own? Very good. What I'm going to do is I'm going to clustering and I am going to hide the last column. I will not give this as an input to the algorithm. I would say, boss, you need to do unsupervised learning, but you have sepal length, You have sepal width, you have petal length, and you have petal width. Only 4 columns to play with. Okay. Using these 4 columns and 150 rows, can you form 3 groups of flowers purely by the dimensions? I'm not going to tell which category they actually belong to. Purely by the dimensions, can you tell me, okay, so and so row is in group 1, so and so row is in group 2, so and so rows are in group 3. Okay. And then what I would do is, okay, unsupervised learning has done the job. I also know groups. I know that 50 flowers are in group 1, another 50 flowers are in group 2, another 50 flowers are in group 3. From a mathematical perspective, to understand the nature itself. Now, here is my biggest question. If you are able to answer this, you understand unsupervised learning. Why do I say this is not an ideal context of unsupervised learning? These are there and you know what groups are there, you would never do unsupervised learning. Unsupervised learning should only be done when you don't know the answer, when you don't know the groups, you want to explore, you want to understand the patterns, and only then unsupervised learning can be applied. But we are tweaking the version of it. Let's assume that these species are there. Let's assume, let's try and run, see what is group number 1, what is group number 2, group number 3, and then match it with the species later on. But again, reminding you, not the ideal way. In this case, you already know the answer. You shouldn't be doing unsupervised learning, but just to see how good or bad the algorithm is purely from a mathematical point of view. Shall we do this? Okay. So, first things first, do we need any preparation, any missing values, first of all? No, everything is perfect. Let's look at the data type, stored as string, interpreted as decimal. Ideally, I should do stored as decimal and stored as float or double also, but shouldn't be a problem. These are categories, so shouldn't be a problem. I think all good. No preparation needed. Okay, let's go back to the flow. Okay, so no prep needed. I mean, one step is gone. Do I need training and testing data set? No, there is nothing like 80% of train, 20% test. This is not supervised learning, so we are not getting into that, which means we're actually ready to run the algorithm. That's how simple it is. And that's how it is. Unsupervised learning is simple. You have your data. There is no target variable, nothing that you're predicting. So just take the data, go for lab, and let's figure out where is that option of unsupervised learning. So let's do this. Let's click on Iris. Let's click on lab. Tell me. Auto ML clustering. Now, no predictions. You're not doing any prediction. You're not saying predict this, predict that. It's a different type of AI that you're doing. Let's go for Auto ML clustering. And again, I told you there are various algorithms that can do clustering for you. K-means is one of them. Fractal clustering is another way. Anomaly detection is another way. There is something called hierarchical clustering as well. A lot of different methods. As far as you know, one of the methods, you're good. Other you can try later. K-means is selected by default because that's the algorithm everyone usually fundamentally tries. So no need to change anything. K-means is already selected. Give a name to your analysis. And let's click on create. So this will take you similar tab, design and result. Everything is, there's nothing potential. Let's go to design. And whole data. Yes. So sampling method, I wouldn't want any sampling. So anyway, it wouldn't do, but still to be on a safe side, we would do no sampling. Let's go to features handling. Now you see ID is switched off by default. Doesn't make sense to put ID into clustering. But there is one more thing which we'll switch off. Which is the hiding from the no, we will not make your life easy. We are not going to tell you which category do they actually belong to. That's for us to check how good the algorithm is. So essentially, we will have four things: sepal length, sepal width, petal length, and petal width. Only four things should be switched on. Anything else? Let me check the algorithms. Oh yeah, very important. Now click on algorithms. Now you see the kind of algorithms that it recommends. It's not telling you logistic regression. It's not telling you decision tree. So the tool is quite good in understanding what you want, what are you doing, and recommending the algorithms. All of these are actually clustering algorithms. If you're interested, you can try, few more to see whether other algorithms do better compared to k-means. But for today, we will switch on only k-means algorithm. Now, very important. What do you think this is? What is number of clusters? Number of groups. How many groups do you want? And this is where again data IQ becomes so interesting. It says try with 3, try with 5, try with 7. I can do everything at one go. This is pretty much the tool boasting on its own. Because if it was coding, you would first try with 3 groups, then again try with 5, and then. But here we have a definite objective. And what is that objective? How many groups do we want? 3. So we'll switch off the other options. We will say, sorry, don't do 5, don't do 7. 3 is already there. I want only 3 groups. Okay. But yeah, in a truly explorative stage, which is the real use of unsupervised learning, you would want, I mean, if it is number of customers, you would say, okay, try 3 groups, give me also 4 groups, give me 5 groups also. I will see in which case, more meaningful groups are formed, and I can take it forward. So in an explorative stage, that option was quite good. You can mention how many groups you want, and you can see all the results at one go. But today, I have objective in my mind, so I will keep the number of clusters as 3. What else? I don't think anything else is required. Let's click on save. Let's click on train and give a name to this as trial 1. All right, so let's do the interpretation first. You get the outside results. One big caveat, this is not accuracy. There's no concept of test and train, which in logistic regression and decision tree, you look at this number and say, oh, this is accuracy. This is nothing, no interpretation over there. Unsupervised learning doesn't test anything for you. It hasn't tested it on species data or anything. It had only 4 columns. It did 3 groups for you. Again, this is not saying that cluster 0 is more important, cluster 1 is less, nothing like that. So it is just a common way of showing the it shouldn't do interpretation at this point of time. No accuracy, no feature importance, because that's not the objective of what we are doing. The only thing what we are doing, we had 150 flowers. Some of them we want in group 1, some of them we want in group 2, some of them we want in group 3. If you want to see what actually happened, let's click on k-means and go inside the actual trial results. And now you see some important answers of k-means clustering. So it says, I did the clustering for you. In group 1, there were 50 flowers. In group 2, which is cluster, there are 56 flowers. In group 3, there are 44 flowers. Remember, your names of clusters could be different because anyway they never existed. It could be group 1, 2, 3, it could be 0, 1, 2, 2, 1, 0, whatever it is. They never existed at the first place, but it did form three groups for you. First group has 50, second one has 56 plus, and the third one has 44. Now, have a look here. This is where the tool is so brilliant compared to coding platform. In a coding platform, it would have done the job and stopped over there. But here, it has started giving you some knowledge also. It says petal length is an average 61% smaller and mean of 1.6 against the global so and so. Petal width in cluster 0 is 79% smaller compared to global and things like that. And when you click on the next cluster, so have a look, cluster 1, also it gives you some interpretation. Cluster 2, also it gives you some interpretation on how cluster 2 is a bit different from cluster 1, is a bit different from cluster 0. All these insights are quite interesting. Also, you can name these groups. Let's do that. So cluster 0, I will rename this as group 1. Cluster 1, I will rename this as group 2. And cluster 3, I mean, cluster 2, according to data IQ, is group 3, so that I don't get confused with the names. So I gave my own, you can say G1, G2, G3, you can give 1, 2, 3 if you want. I have just renamed them as group 1, group 2, and group 3. Now, if you see clusters and if you see heat map, it is drawing the maps already for you. It will say, okay, if you look at group 1, this is how petal length behaves, this is how petal width behaves. Blue means low and red means high. So in group 1, petal length and petal width are considerably lower than group 3. So purely by colors, you can start understanding the differences between group 1, group 2, group 3. All this is fantastic piece of information. You can have cluster profiles. You can choose, and again, this is brilliant from the tool. Imagine for everything in coding, you will have to draw a separate graph, you will have to do this. Here, everything is done for you. Just choose which parameter you want, see the graph yourself, understand whether grouping makes sense or not. All this is available at your disposal. And you can have as much information as you want about your group. Okay, now, very, very important. All this is great. You have given me all the information about differences and all that. What I am keen to see is where did you add that column where you said these rows are group 1, these rows are group 2, and these rows are group 3. Can you tell me where do I check that? Predicted data, absolutely correct. Let's go on that. So this is all report, which is great value added information, but my real stuff is here. Predicted data. And you see the magic that it has done. It has actually added cluster labels for every single row. And look at the damn accuracy of mathematics. It is unbelievable that purely by math, if it can understand, which category the flowers can belong to. Of course, there are a lot of errors. I'll tell you where the errors are. But first impression is mind-blowing. Look at this. All the Setosa flowers almost are captured into group 1, and so on. Let's have a look at full thing. Looks pretty good. E is mixed between group 2 and group 3, and also some. Okay, now here is a task. Let's see if you can achieve this. Question: Nothing, nothing. So it's just groupings have been only done by mathematics. And everyone, let's see how good you are now. Imagine, and this is a data IQ task, so nothing related to unsupervised learning. Now you remember this confusion matrix sort of a thing that we saw in logistic regression. I want you to do something similar. For I want you to make a sort of table. I don't know how you will make that table, where you say, okay, Setosa flowers, Versica, whatever it is, Versica and Virginica, and how many of them actually were classified as group 1, group 2, and group 3. 3 cross 3 table of the flowers versus the group prediction. Where can I make such sort of a table? All right, good. That's great option to begin with. What do I check? Pivot tables. Nice. Let's do this. Pivot tables. What do I put in rows? What do I put in rows? Okay, let's see cluster labels in rows. What do I put in columns? Species. Good. You guys are good. Okay. And values? Count of records. Let's try this. Actually, we can reverse it. If we reverse, it will be much better interpretation. Let me put species in rows and cluster in columns. That gives me a much better idea. So I've just swapped the rows and columns and look at this mind-blowing thing. In Setosa, there were a total of 50 flowers, and all 50 of them, all 50 flowers got clubbed into group 1. Massive, massive win for the algorithm. In Versicolor, total of 50 flowers were there. 39 of them got clubbed into group 2 and only 11 misclassifications into group 3. Virginica, there were 50 flowers. 33 of them got classified into group 3, only 17 misclassifications. So out of 150 flowers, how many flowers did it wrongly assign to the group in total? 17 plus 11, which is 28. That's it. Purely from a maths point of view, it was able to analyze the petal length, petal width, sepal length, and sepal width. And without us telling which group do they belong to, it did a very, very good job of clustering, and it gave us mind-blowing results. And again, as I said, in this case, I was just experimenting. I knew the results. I would actually not use unsupervised learning, but I just wanted to check how good this k-means clustering algorithm is. How can this be a part of your hackathon? Imagine you are doing your prediction model and everything. The last task can be that can you divide your customers into 3 groups and tell us whether you found any meaningful groups or not. That could be one of the tasks. So you did your prediction model, you did logistic, you did everything, you did a use case. The last task is after that, can you have 3 groups of customers? So whatever data is there, you subject that to unsupervised learning, you get the groupings, make sure you know where to check the grouping. It's always in predicted data, and make sure you know you can label those groups as group 1, group 2, group 3. In another case, you can say customer group 1, customer group 2, customer group 3. Label, see the output, and then go to charts and see, or you can even analyze it from here. So if I do cluster labels, analyze, you can see how many were in group 2, how many were in group 1, how many were in group 3. This is quite fix. Let's look at cluster ID. 56, 50, and 44. So basically it's the same. So group 1 corresponds to 0. Group 2, it's the same, exactly the same. It's just that they have given an ID of 0, 1, and 2. That's it. So it's just a good added feature to have, nothing different. It's exactly the same as group numbers. Yes. Correct. That's correct. So because it will approximate. So it can never be accurate. Clustering. So for example, if I ask, these are student groups, it can never be accurate that it will give me this is group 1, 3. Clustering purpose itself. Now, guys, very, very important question. Remember, the purpose of clustering is never accuracy. For example, you have 100,000 customers with you, and you're saying group 2 can we get some common patterns in group 3? There's no question of accuracy. You cannot say, oh, group 1 people should have been in group 2 should have been in group 3. In this case, we can because we know the final answer, and that's why I gave a warning. You should never use unsupervised clustering for this because in this case, you already know the answer. If you already know the answer, why are you doing the algorithm, right? That's the big question. In a customer data set, you would never know. You're saying to see 3 groups. I will try and figure out if there are some common patterns in group 1, some common patterns in group 2, some common patterns in group 3. You can never say, was it accurate? Was, group 1 that I should have been in group 2? You can never make out. That's why it is unsupervised. There is no target variable, there is no prediction, there is no accuracy. You are exploring from the data. And on 100% of the cases, you never get accuracy. You never target 100% accuracy.
What we done is, the results that we got is not except for the group one.
No, so that's what I'm trying to understand. Make you understand this was not purpose. So I was not trying to say whether the algorithm is 100% accurate or not. What I'm trying to say is if it is forming groups, is it still capable of forming meaningful groups? That's the only thing. And there is meaningful group. You have group 1, which behaves very differently from group 2, very differently from group 3. Obviously, you cannot expect that to pinpointly say, okay, these will be setosa, these will be versicolor. We never get that as an input. It's an approximation. That's why it is unsupervised learning. We are just trying to find patterns. And I knew this could be a confusion. So once again, I repeat, the purpose of today's exercise was not to compare accuracy. Never. In fact, this is not even a great case of unsupervised learning. Ideally, imagine you never knew Setosa, versicolor, and virginica. You never knew they existed. You say, okay, these are the flowers. Do we have some common patterns? Something in group 1, something in group 2, something in group 3. And you would say, oh, in group 1, they have larger petal length, sepal length. They have small length and sepal compared to the other group. So we are exploring features, we are exploring patterns, and that's why it is unsupervised learning. Make sense? So you're right. I mean, technically, it's not 100% accurate, but that's never the objective of what we are doing. We just wanted to have fun with the algorithm to see is it capable of at least forming meaningful groups, which definitely is more than capable of doing that. Any other final questions? Yes. Unsupervised learning. And I say, can you form 3 groups of accidents? And then I understood that certain events which have happened, they reveal a particular pattern. In those, the temperature humidity was this, and it led to a more fatal accident. And you would say, wow, that's an interesting pattern. In another group, the temperature was lower, humidity was higher, but the casualty was less, let's say. And you would say, oh, that's again an interesting pattern. So you try and understand with the help of if it forms meaningful groups. So if your objective, and one of the objectives is, can I have meaningful patterns in my data? For that objective, you can do unsupervised learning. But if it's not one of your objectives, you might not want to do unsupervised learning at all. Just do random forest decision tree logistic regression for whatever you're predicting. So it depends on your objective. And now you should be able to, so to everyone, very, very important. I said the minimum mandate in coursework 2 is your doing 2 algorithms. Either you can do another algorithm for unsupervised, which is another objective. That's your wish. Or you can do both for the same objective. So 2 algorithms is what we want. Whether it fits in some context, it might not fit. If it's not fitting, you're not seeing grouping is in any good objective, you might not ignore it.
So, sir, this trophy number is shown. So it will matter in the
The time of execution. Multiple if it's showing which case it took the least time, and that's it. So it doesn't matter. That number doesn't matter at all.
but it's supervised.
It's supervised it matters because that's your accuracy of the model. Yes, definitely. Anything else that I can clarify? All good. So all of you are now confident on the new data IQ accounts for the next 2 weeks. You'll be using the same. Get comfortable. It's called Launchpad link. Your personal email ID and password. Private. It's not discoverable. Remember, in mock hackathon as well as main hackathon, the main data IQ link of the university will be disabled. So you will not have access to that. You'll have only access to this one where you will be completing your hackathon.
Those projects are given us.
There is a way to export it to zip in the personal account. I wouldn't recommend that because personal account is only for 14 days. So actually, it should be the other way. From your personal account, you should switch it back to the data IQ account. So this will close in 14 days. It's mainly for the hackathon. Sorry. Only because there is no, again, that's a good question. In a supervised learning, we usually deploy so that we can get an unknown data set, pass it through the model and get some predictions. Here I got what I wanted. So ideally you can, but there's no need. If you got what you want, you can. Next week. Yeah.
With your customer data.
Sorry.
Data need to sort it into groups for me.
Correct.
So I should understand that there is a relation in these groups.
Mhm.
And I can classify myself. I can understand it. Move.
You can understand it yourself.
That is objective.
Yeah, but data IQ gives you some parameters. So for example, now if you saw the models, go to visual. Yeah. So for example, when I see the thing itself, you see heat map. Now data IQ itself is giving you some hint. So it's saying, look, this is low and this is high. So I would say, oh, in group one, what is happening is the length and width is lower compared to this as compared to group three. In group three, all these are higher compared to the sepal width. So, from the heat map, I can understand. From cluster profiles, I can see the graphs and understand. So a lot of the things you can understand here itself. But thank you. But if you want, you can draw additional graphs and see if it is.
So like if we only choose like 3 groups.
Correct.
So if there were like 7 groups.
Correct.
Groups,
Hmm.
give us like 8 options.
Yes, and that becomes very complex. So people generally don't do 8 grouping, 9 grouping. 3, 5 are usually the ones. 3 to 5. Yeah. Because beyond that, then there are 2 small patterns in group 1 and very different patterns in group 7. Very different patterns, unless there is a requirement that you need to break it into 9 groups. Otherwise, you wouldn't do 9. Yeah, good question. Online students, any questions? Dipayan, go ahead, please.
Yes, sir.
Hi.
Yes, sir. So those class can be later.
Done, done. The class is done. Thank you so much.
Fine, sir.
Sir,
Thank
I
you so
just had
much,
a
sir.
quick question.
Go ahead.
So, for the coursework, we're okay to do it on the student data IQ. That's fine.
Yeah. So in coursework, I wouldn't recommend this trial license.
Okay, got
Yeah,
it.
just do it on
And,
your regular MDX student one.
got it. And when we're done with the work we're doing, like in the hackathon or so, how do we how are you assessing it? Is there a way to extract this data, or are you
No need to do
assess-
that. So I'll tell you once we do the mock hackathon. So basically, my question, and you would say question number 1, you did data preparation, give a screenshot of that. So you just take a screenshot, put it in the Word document. So you don't actually upload your data IQ file, you upload the screenshots which are needed.
Got it. And just to confirm once again, we can use our personal laptop or devices for the
100%.
hackathon, right?
100%
Okay.
yes.
Okay, thank you so much.
All right. Yes. Oh, so this dashboard was not there, right?
Yeah, this was not there.
Nice. Interesting. And it gives a summary of everything.
And all, and here is your
These are in working right now because
Okay.
there are some API problems that
Okay.
I'm facing.
But very good overall interface. Nice.
I'm planning this for the AI hackathon.
Oh, AI hackathon.
Yeah.
But do you have a theme in AI hackathon?
So yeah, they have given that for a business problem you have to decide.
Okay.
So this is also one.
Okay.
And the Jarvis one I just told you. We did this to that.
Nice. Good job.
So, just QR code for the attendance.
Attendance? Sure.
Yeah.
Thank you. See you. Yeah, yeah. Do you want the QR code or manually? Okay. 1 minute, I can just put it in. Okay.
Thank you, so.
Thank you. Yes, I will be posting that. Yeah, with the links and everything.